So what I'm talking about today, just a little background. One of the services that my company provides is a software cost estimating tool, and part of my job as the chief scientist in charge of cost research is to study new and emerging technologies and try to help our clients either with our tool or through our services find ways to estimate as they're moving into new technologies. So what this presentation is about the different flavors of cloud computing. So, excuse me, I'll start with an introduction. Why am I here? Why am I doing this? And then I'll talk a little bit overview of what cloud computing is, the different platforms and the different as-a-service models. And then I'll talk more specifically about those as-a-service models as to what might be the right one for an organization depending on both their needs, their budgets, and their skill sets. I follow this up with a case study. It's a notional case study where I will take you through a notional decision process for an organization that's considering cloud computing and is trying to determine what would be the best as-a-service solution for their needs. And finally, I'll just wrap it up. So, as defined by the National Institute of Standards and Technology, cloud computing, it's a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources, so things like servers and storage devices and network devices. They can be rapidly provisioned and released with minimal management effort or intervention of the service provider. 90% of medium to large enterprises plan to increase or maintain their annual spending on the cloud in 2016. CIO magazine has decided or predicted or announced that the battle of infrastructure is over. So organizations seem to be getting more comfortable with outsourcing their backups, outsourcing their storage, at least partially, not maybe totally. And but the new battleground is in the application space. Thus, the reason that we're talking about the different as-a-service models. So, and specifically, we're focusing on the issues of migrating applications to the cloud. So, application migration, it comes with challenges. How does an organization determine what is the right solution to migrate to or host in the cloud? And how do they identify the right platform for migration? And what challenges are presented by the various cloud solutions? So we have infrastructure as a service, where one provisions hardware and hardware-like devices through the cloud, but then manages from an IT perspective the software side of it. Platform as a service, one once again uses hardware in the cloud and also some development platforms, but they do their own development and deployment via the cloud. And then there's software as a service, where one takes advantage of applications that exist entirely in the cloud and just basically rent space in those applications. So this paper is going to define the different solutions in more detail, explain some of the implications of each, and then present, as I mentioned, a case study that will sort of walk one down the path of what's my thought process, what cost do I have to think about, what's the thought process, what different skill sets might I need than the ones I already have. So basically, there's 5 tenets of cloud computing. There's on-demand self-service, there's resource pooling, there's broad network access, rapid elasticity, and measured service. So what does all this mean? On-demand service. So IT resources are available when and where they are needed. All one needs is a device that can connect to the internet and the connection to the internet. Broad network access, so that just what I just said, all one needs is a browser and a network connection. They can do that from anywhere. Resource pooling, that means that the location of the data centers is irrelevant to the end user. This allows cloud providers to pick locations where real estate and power and people are more affordable. Virtualization allows for rapid elasticity. What that means is that an organization that has peaks and valleys in their demand for computing resources does not need to provision for their peaks. They can provision for their average processing requirements or computer requirements and offload to the cloud when things are, when things hit the peaks. And measured service. Obviously, this is a utility kind of model for using computer resources and software, meaning that, like the water company, the cloud providers need to measure the amount of activity that goes on in each account so they know how to bill. They also measure for the quality and such of the service that's being delivered so that they can automatically optimize performance that gets delivered to the end user. So there's various platforms that one might move into the cloud on. The public cloud, that is available to anybody on the internet willing to meet the terms and conditions of their cloud service provider. Or key characteristic of public cloud computing is multi-tenancy, meaning that you are running an application and storing data in a space that other people are also occupying. And while virtualization creates separate environments, there's still, the issue of multi-tenancy is one that concerns some cloud consumers. Cloud computing infrastructure and technology, they are taken advantage of, but in the not multi-tenancy or public environment, but rather operating for a organization or a department or an agency. They could be housed on-premise, or they could be housed remotely as long as the proper security and firewall kind of situation is recognized. They could be run with internal resources or a cloud computing provider. And they service a single customer. And the customer could be very big. It could be the U.S. Army, but it's a single customer. And the only people that would have access to a public cloud are those people whom the single customer grants access. A hybrid cloud, which is Gartner's predicting that 50% of all enterprises will have some sort of a hybrid cloud solution by the end of 2017. So organizations take advantage of the public cloud in areas where it makes sense, and they intermingle that with some private cloud applications or private cloud instances for things that they want to keep on premise or for things that they don't want to share space literally or virtually with other people. And then we have, once we've determined whether we want, to be public or private or some sort of hybrid of the two, there's the issue of picking the right as-a-service model. And there are more than three, but these are the three main ones, and these are the ones I'm going to focus on. So infrastructure as a service, the computer infrastructure is being accessed via the cloud. The cloud provider manages the hardware and the network. The cloud consumer manages the operating system, the middleware, any other supporting applications, and the data. With platform as a service, once again, the hardware is part of the service. The development environment is accessed through the cloud, and the application is deployed through the cloud on the cloud provider's hardware system. The cloud provider manages the infrastructure, the supporting software, and the runtime environment. The cloud consumer still does the development of their applications and manages those applications and the supporting data. Software as a service, software applications are just accessed through the cloud, and the data is maintained in the cloud. The cloud provider provides the entire software stack and all supporting hardware. The cloud consumer may have to migrate their data to the application, but then they access the application and the data through